In this video, I want to show you a second technique for how you can factor trinomials. And remember, trinomials have three terms. And this uses the grouping technique that we saw in a previous video. So this technique is not trial and error. Students tend to like it because it's very systematic. So you just follow the steps and you're going to get to the answer. Whereas with trial and error, there's a lot of guesswork involved. Trial and error is great if you are good at multiplication and you're good at mental math. If you're not, it can take you a really long time. So this is a nice alternative method that you can use. So what we do here, we still have that same initial trinomial, but instead of factoring A and C separately, you're going to multiply them together, and then you're going to list all those factors. And what you're going to do is find the factor pair that adds to the middle term B. Our next step is to split the middle term so that we can make it into a polynomial of 4 terms, and then we can apply factor by grouping. So let me show you how it works. So here, A times C, well, this is your A, this is your C. So we're going to do 1 times 8, it's positive 8, so I get 8. And then you're going to list the possible factors. So 1 and 8, -1, -8, 2 and 4, -2 and -4. And again, I list all the sign possibilities. It just makes it easier. And what you want to do is find the one that matches with +6. So if I'm looking through, I see that this is going to match because +2 plus +4 is +6. So that's the one we're going to use. So what you're going to do is you're going to take that initial trinomial and you're going to split that middle term using these factors. So instead of using 2 and 4, you're going to use 2x and 4x. And what your problem is going to look like is x squared plus 2x plus 4x plus 8. So the original values in the beginning and end come down, and that middle term just gets split. I haven't changed the problem, right? 2 plus 4 is still 6. It's still the same trinomial. I've just rewritten it with 4 terms now so I can use my grouping technique. And now you're going to factor by grouping. So I can take the first 2 terms and the last 2 terms. Remember, we find the GCF of each piece. Here, my GCF would just be x. So when I factor that, the x comes on the outside, and then I have x plus 2 left over. My GCF here is 4, so the 4 goes on the outside, and then I have x, and then 8 divided by 4 is 2, so I have x plus 2 left over. And now you're going to notice those matching terms, and that's going to be your new GCF. So we're going to factor one more time. New GCF goes on the outside, and then what's left over? I have an x, and I have a +4 left. And that is my factorization. You can still check this by multiplying. So maybe I'll do one check here for you guys as well. So if I multiply out, it's always good to check just to make sure you didn't make a silly mistake along the way. I'm just multiplying that out, and I can combine those middle terms, and I do get that 6 there in the middle. So it does check out, and I'm done. There's no trial and error. There's no guesswork. The only real trial and error is really up here, just finding which terms to use when you split. But that's it. You're going to have the answer. And again, a lot of students like this because it's a bit more systematic. You have to be good with factoring by grouping, though. So if you're not, go back and watch that video again and spend some more time there. But if you understand factoring by grouping, then I think you're going to find that this technique works out really well. All right, so let's do another example. I'm doing actually some of the same examples from the video on trial and error, and then that way you can kind of compare the two strategies. Again, you would still look for an overall GCF. My GCF is just 1 here, so I'm not going to factor anything out. And I start by looking at A times C. So my A here is 1, and my C here is -14. So I have 1 times -14, which is obviously -14. And then I list all my factors. -1 times 14, 1 times -14, 2 times -7, -2 times -7. And what I want here is I want that number in the middle. So I want to add them to match. And the one that works here is this one, right? 2 plus -7 equals -5. So what I'm going to do is I'm going to take that original problem and I'm going to go ahead and split it. So I'm going to write it as 2x plus -7x in the middle. And when you rewrite it, it actually doesn't matter the order. If you put the -7 first and the 2 second, it's still going to give you the same result. And now I'm going to go and factor by grouping. So here my GCF would be x. And when I factor that out, I'm left with an x plus 2. Here, both my terms are negative, so I'm going to factor that out as well. So my GCF here, so GCF is x. GCF here is -7. And I'm left with also x plus 2, right? -14 divided by -7 is +2. So I see that new GCF again. That becomes one of my factors. And then I have an x and a plus -7 or a -7 left over. Now I'm going to let you check that at home, but you're going to see that it does actually check out. Okay, so here's one of those harder ones where you don't just have an x squared up front, but the same process is going to apply. So again, it's kind of nice. This tends to be a favorite method of a lot of students, those particularly who have struggled with factoring. So 8 times -3 is -24. And I'm going to break this down. So I could use -1 and 24 or 1 and -24. I could use -2 and 12 or 2 and -12, -3 and 8 or 3 and -8. Lots of options here. -4 and 6 or 4 and -6. So what I like to do is I just go right down the line. I try 1, 2, 3, 4. I would try 5 next. The nice thing is that once you start looping around again, see how there's 6? I don't have to keep going. So if you go in order, once you start looping around, you see that digit already there, then you know you have all your factors. So I'm looking for that -10 now. And let's see. This is the one that looks like it's not even the -10, right? 2 plus -12 is -10. So be careful. I know 6 and 4 look like they're going to work, but when you add those values together, you get 2 or -2. They don't work. So the one that works is 2 and -12. And there's only one combination that should work here. So you're not going to ever find that there are multiple combinations. If you do, then you did something wrong. So I'm splitting that term. And I'm just going to go ahead and apply my factoring by grouping. So my GCF here is going to be 2x, right? They each have a 2 and they each have 1x. So let's see, 8 divided by 2 is 4. So this is going to be 4x. Now, I know I took the whole thing out. I do need something. So you're going to put a 1 for a placeholder. Here I see a GCF of -3. So I'm going to take that out. And then I'm left with 4x. And again, I need something there. -3 divided by -3 is +1. I have that repeat value. So that's going to get moved out here. So 4x plus 1. And then left over is 2x plus -3 or -3. Now, if you think back to the video on trial and error, this problem took us quite a while. There were 8 different options that we could have tried. Whereas here, yeah, we had a lot of factors to go through initially, but once we did, it was very, very systematic. So again, if you're a type that struggles with factoring, this method is probably the one for you. particularly if you're not great with the multiplication tables, because you really only have to do it a little bit, whereas in the other one, you're constantly multiplying everything back out. Now, still double check your answer, right? Make sure there's nothing else you could do there. I can multiply this back out and check. So this technique works really well. All right. So I'm not going to do the last two examples that we saw in the trial and error video because it's going to be the same process, but I encourage you to try them. You have the solutions from the factoring by trial and error video. So this technique works for if you have multiple variables. So I know in the other video, we saw something like this, right? So you could apply that same technique here. It's going to work as well. And then when you split the middle term, you're just going to split it with the xy instead of just having x. So you'll have one factor xy and another factor xy. It works the same way. And it also works on perfect square trinomials. Again, you don't even need to know that it's a perfect square. You're just going to go through your regular technique. And as you're doing your grouping, you're just going to get a repeat factor at the end. But it's the same process. So give those two a try by grouping. If you have questions, you can reach out to me, but you have the answers from the other videos. So it's a good way to check, to practice, know what the answer is, and see if you're doing the procedure correct.